Next up will be Christine. Right. Christine is a PhD student in Darmstadt. She has just started. She wants to and will work on ceramic additive manufacturing. It has actually done some work in her master's thesis. I think you're going to present some of this and then additional things on ceramic 3D printing. Stage is yours.
Hello, everybody. So since I'm in a really early stage of my work, plan is to just like first present my master thesis, which is, wie klicke ich weiter? How do I do it?
What you want?
Like next sheet. It's not like really working for you. Where's the mouse?
It should be there. But no, it's okay. It's okay. Okay, check here.
Yeah, okay. Now it's working. Yeah, so it will be two parts. One of the is the parametric design and evaluation of AM brickwork, which used to be my master thesis a few years ago. And since I just started, like we have an idea about like what I want to do research on in the future, which would consider acoustics in cities, and also take into consideration AM with ceramics. So parametric design and evaluation of AM brickwork. That was pretty much about like we had the process that worked, just printing with ceramics, and we're looking on how to use it. So the first thing that was pretty much investigated was on how to make better bricks, more or less. So we thought about several designs that were aiming at exploring the design potentials of AM for masonry wall constructions, and by optimizing the filling pattern. And so we were generating geometries that were not producible within traditional methods. And the basis for all of that was a literature research, first on the state of the art, and then also just like taking into consideration that we wanted to produce something that was not producible before. So closed cavities, and with like having in mind on like optimizing the thermal conductivity, but also just at least kind of considering in the design the acoustic properties. So we had the three designs. The first one was pretty much just like several pyramids, more or less. And then we had like different kind of waves that were interacting, like the regular ones, and then more or less pointy, edgy waves. The designs were constructed with grasshopper and rhino. The first step was just like basic input of things like the height, length, width, outer and inner perimeter, and like the standard characteristics. Then everything was produced, like the geometries were produced in a base layer and then just mirrored over the height of the brick. Initially, the plan was to produce like actual whole bricks, but since we had some technical issues, we had to compromise on using a smaller 3D printer, which was the Lutum that a lot of you are also working with. With that, like the production time kind of forced us to only produce smaller specimen of the designs. So we ended up doing the ones on the left side for the compressive strength tests, and the ones on the right side for the thermal conductivity tests. Yeah, like those were the specimen that were produced in the end and tested. And considering like the thermal conductivity, the commercial design performed slightly better, which is shown on the very left, like the dark blue values, than the other ones, but in general, they are all like kind of close. The thermal conductivity, just regarding the absolute values, also the commercial infill pattern performed slightly better than the parametric design. Here we just had like one design that was tested, but like also taking into consideration the density, you could interpret that the parametric design is even almost slightly better, taking into consideration just that it has like a higher density, but the values are slightly better, like some of them, than the commercial infill pattern. So that was pretty much where I came from, like a few years ago. And now we still have the process and are thinking about like what kind of usage we could have for it. And one thing that came to mind was just acoustic bricks, since, and like TU Delft, for example, or also the University of Applied Science of Frankfurt, they are already doing research on how to design the facade in order to make acoustics within cities better, because usually, like the picture on the left shows that you have the direct noise, and in addition, the reflected noise that makes up for that urban noise level at the receiver. And usually in cities, you just have like those very prestige high-rise buildings, like shown on the right, that have hard reflective acoustic properties, and like even worst case facing down, so reflecting everything back towards where the receiver is standing. So in order like to reduce the noise level, you could do it by dissipation, absorption, or reflection. And like probably the most feasible is reducing the reflection of a facade, or enhancing the absorption through its geometry, since engineers or architects can't really do anything about the noise source itself. So the plan is more or less to find a design to enhance the acoustic properties, since so far only outside-inside is considered when planning a building, or inside-inside, but not really outside-outside itself. And the approach, like one of the possibilities that I found was very interesting, was the absorbers that probably most of you also saw at Beam, which kind of is about passive destructive interference. So that interfering sound waves at a counter phase would cancel each other out. So to design an absorber in a way that the maximum and the minimum of sound wave would meet, and just like cancel each other. But here the problem is that it's for a very specific frequency. So it might be hard to realize in a city with a lot of different noises, but it could be possible to maybe just like aim for the ones that are most disturbing, and kind of include that idea in the whole research. And the other one would be controlling it by controlling the reflection. So there were different designs proposed in the research of TU Delft that kind of took into consideration the reflections caused by a material, and just scattering the sound in the way that is shown on the right top, or like changing the design and having like really complicated structures for the facade that are also scattering and reflecting the sound in ways that don't reflect it back to the receiver. So taking this into consideration, like what we now called acoustic bricks would just merge everything, like additive manufacturing with ceramics, parametric modeling, facade design, and acoustic engineering, since the patterns that are necessary to do so are more complex, and the freedom of design that is provided by additive manufacturing would just play into that, into realizing those complex geometries. And just also with the parametric design, obtaining a redundant facade design and being able to change the design quickly and observe different possibilities. The acoustic engineering, since I'm not really into acoustic too much, we were planning on doing that kind of project with the acoustic lab at our university from the mechanical engineering department. And so it would be more or less a collaboration. The research questions would be like, in general, how can positive characteristics for engineering of urban outdoor soundscapes be integrated in the facade? and which digital processes are necessary. Like considering those processes, acoustic simulation and the development of design parameters would be an issue. A parametric facade model, and like always the translation into printing data. Obviously, also optimizing process quality of additive manufacturing further, and like having the same quality, reproducing those acoustic bricks, and kind of further looking into what is printable and which restrictions occur process-wise. So which possible strategies are there to reduce the impact on the design? And obviously also doing testing on the mechanical performance as well as the acoustical performance. So that was just like a brief overview, because I'm more even in a pre-stage of doing my research. And I really wanted to present those ideas, and I hope, like, I'm really looking forward to any kind of questions or feedback on that. So.
And again, I'm ready to be.
Hi, thank you for presentation. And I have one question. Do you want to still keep into your process the possibility of, do you still want to embed the thermal properties inside your bricks, or it's just going to be acoustics?
It is like, we haven't really focused on that yet, but it would probably also be something to be considered. Also, maybe another thing we thought about was like green facades, which would kind of play into the like enhancing the acoustic properties, but also the thermal ones. So it's probably definitely going to be a part of it, but not like the main reason for it.
Okay, I was just asking that because in that sense, the geometry, while you're working on the geometry for the acoustics, maybe you can have a negative effect towards the thermal properties.
Yeah.
So I was just asking that.
Yeah, because that was also like in my master thesis that we haven't really considered it with tests during my master thesis, but usually those are like counterparts, like the better, like you need a lower density for the thermal conductivity, and like a higher density is better for the acoustical properties. So yeah, it's not like the focus is going to be on the acoustics.
Okay.
But probably also doing some tests on the thermal conductivity. But yeah, we took that into consideration.
Thank you very much.
Yeah? Yeah. Okay. Well, thank you for the presentation, and it's also kind of nice to see the beginning of the process, huh? And I was wondering if you're going to take into account the scale on which you're going to work. Like the previous presenter, you saw the different scales where you can do an intervention with the ceramics. And as you also mentioned at the beginning, it takes quite a while to print one brick. And if you then consider also the tall building you were presenting, then how would you go about this?
Yeah, the idea is also not to do it like for a high-rise building, like all the floors there are, but maybe just the ones at the bottom, which probably and also more of pattern probably. But additionally, we also hope that the production speed is gonna get better over time. Like first of all, we're supposed to work with a robotic arm, so this is definitely gonna be quicker than what I had to work with during my master thesis. And then also something that we aim to investigate is how to make the whole process like quicker, or like you could simultaneously produce things. But yeah, that's definitely something that has to be taken into consideration. But right now we still just focus on how we could use the process that we have, and then on how to improve it to actually make it better. But it wouldn't instantly be feasible to use it and implement it on buildings everywhere.
Because I think it could be interesting.
Because I think it could be an interesting design parameter to work with, to speed up and to.
And there's one little warning.
And there's one little warning. You said that you want to make closed cavities, and in a masterpiece you were talking about
like
positive,
that. Yeah.
but it's dangerous when you put it in the kiln, it will
In the what?
explode. When you put it into fire.
Oh, but those worked.
Yeah.
Well,
Then you were
right,
lucky.
and like the picture before, that
But
was,
they were not really closed then.
they were closed, kind of like, you could see the top layer, like it's open, but like everything in between, those are closed. Maybe it worked because they were a small specimen, like we weren't able to print the big ones. But here we just had them dry for, I think, a week. And also just like we put something on top, so the shrinkage was kind of controlled and the cracks. And then we fired them, and also the firing took a pretty long time, and you left them in there overnight to cool down slowly and everything. I don't know if that played into it, but the specimen themselves, at least from the outside, they didn't look like they were broken.
No. Then you're lucky.
Yeah.
That's it.
Further questions?
I just wonder, have you tried to figure out, like, looking at the images there, how they will be interacting? The units with one another? Is it mortar? The units with one another? Is it mortar? Is it mechanical fastening? Are they suspended, or how are they
I'm not
working
sure.
with each
I
other?
think I didn't understand the question.
So this is,
Yeah,
those
like
are
those
units,
were
right?
infill patterns for actual breaks, like what you have right now, and those were supposed
Exactly.
to be closed.
Just the info patterns. Okay, and how, once you have one break,
Yeah.
are you using conventional mortar between them?
Oh, you mean like just building it up?
Yes.
Everything? Like, back then, that was the plan, like it wasn't, you mean like instead of an interlocking system or something like
I'm
that?
asking you, so which one, is it interlocking or is it mortar, or are they cladding only? How are they working together?
Like all the other, details about would like be the same. This was just really focusing on just, designing a different infill and kind of testing it. But it was supposed to just be mortar, like that was 3 years ago, and it was really just about trying out different geometries and doing testing and see what we can do, and if it makes anything better, just the brick itself,
Okay.
not really taking into consideration like building a whole wall out of it back then.
I mean,
Because-
I don't know where your research will go, but I think we found that it was as a comment, designing where the mortar goes in relation to the unit can have a huge impact, because it tends to, sometimes it's heavier than the units themselves, depending on how it's done. It could be a really valuable kind of dimension to consider
Yeah.
as you're kind of moving forward.
Distance ourselves kind of from, because it's not really useful to print regular bricks in general. Like it would take way too long, and the regular processes are just way more efficient. So that was just, we were testing it, but not really going deeper into it afterwards.
Thank you. I guess it's not really a question. I think it's a kind of comment and questions for everyone, also for Ulrich, I guess. And for me, one of the most difficult things in this moment, of course, one is modeling the behavior of the ceramic material. To know how it's going to shrink, how it's going to have deformations, such as the one that Isabel and James was showing. And the other thing is the time consuming that it will still take to customize the use of additive manufacturing for ceramics. Namely, if you compare to using of concrete or mortars, which allow us to build in a bigger dimensions, still in a additive manufacturing. In ceramics, we still attach to a smaller, smaller components, right? And if you're following customization, it's until each dimensions I will be able of applying these systems that we are now testing. I think it's a question for everyone.
What prevents printing those elements into a size of like actual grid size and making components which are of real size? Is there anything preventing the material that she was using, for example, or any ceramic material to be printed at the scale of like concrete, for example?
I don't think so. No, probably. But it's baking. When you use stoneware, of course, you need to bake and takes a lot.
So Waterloo is doing certain sizes. They do certain sizes, and say a typical craftsman brick, that's a size which we are able to handle. Well, we're developing now technology to be used in 10 years' time. So I don't mind. That's what Philip always argues. Well, then you get more roboters and you get them faster and you get all this kind of things solved. So that's not a point. But what I like with that one, we didn't talk before. So I saw this last week, the first time that she's into this field. What I like a lot is it's adding this new performance, which is not, don't get me wrong, just aesthetics, which is a part, but there's an additional performance which then serves you to gather the next financial aspects. And we see that in other projects. He's going to show one where we see this kind of additional potential for performances. And that's what I also understood in the beginning of this session. This is pretty much the next level we have to look at. It's not only because we can do, but it's also what does it deliver for the next as an additional value. And that's exactly where this comes from.